Welcome back, everyone. If you're a focused learner who is just absolutely tired of staring at hundreds of lines of messy, repetitive code, well, you're in exactly the right place. Today's explainer is basically the ultimate cleanup solution for your programming projects. We're looking at the core building blocks of writing smart, efficient, and honestly, beautiful code based on the Mastering Python Day 5 Bootcamp notes. So get ready to seriously level up your programming logic. Okay, let's dive into this. We're utilizing Inqilab Patel's incredibly comprehensive Day 5 guide from the Mastering Python for A-Level Bootcamp. And I gotta say, today is a massive turning point. We're officially transitioning from writing those simple, top-to-bottom linear scripts to crafting dynamic, reusable blocks of code. This is the moment where you truly start thinking like a software engineer.
So here's our quick roadmap for today. We're going to cover functions versus procedures, parameters and arguments, returning values, local versus global scope, and finally, the power of modular programming. Let's get right to it.
All right, kicking things off with Section 1, functions versus procedures and their core differences.
So the crucial point is that students very often confuse these two foundational terms, but the distinction is actually pretty simple. While both of them make your programs modular and organized, the key difference is the return value. A function performs a task and returns a value to you. A procedure performs a task and never returns a value. Now, just as a quick aside, Python itself doesn't strictly separate them with different keywords. Basically, if your code block gives something back, it's a function. If it doesn't, it's just acting as a procedure.
Let's take a look at this quick snippet from the text. We define a block called greet, and inside it, we just tell Python to print hello. But notice what's missing here. There's absolutely no data being handed back to the main program. Because this code only executes a print statement and doesn't explicitly return a value, it's technically a procedure. It just does its job and quietly finishes. All right, let's test your active learning right now. I'm pulling a pop question straight from the Day 5 worksheet just to see if you're with me. In the simplest terms possible, what exactly is a function? Take a second and think about it. And here is your answer, a reusable block of code. That word, right there, reusable, is literally the entire goal of everything we're covering today. Instead of writing the exact same calculation 10 times in your program, you just write it once, wrap it up as a function, and reuse it whenever you need it. It saves time, it saves space, and it's going to save you from a whole lot of headaches.
That brings us smoothly to Section 2, parameters and arguments, and how we pass data.
Now that we have these great reusable blocks of code, we obviously need a way to pass data into them. I want to make these distinctions crystal clear. Think of a parameter as an empty box. It's a variable or a placeholder that sits inside the function, just waiting. The argument, on the other hand, is the actual physical item you put inside that box when you're ready to use it. So parameter is the placeholder. Argument is the actual value. Simple as that.
Let's walk through this code snippet together to see it in action. In that top line, where it says def greet name, name is our parameter. That's the empty box. Then, down on the bottom line, where we actually call the function with greet Inqilab, Inqilab is our argument. We're putting Inqilab right into the name box, so the program will ultimately print hello Inqilab. Makes sense, right? Let's throw another quick interactive milestone at you from the text's quiz section. What happens if we set up a box, a parameter, but the user completely forgets to give us an argument to put in it? This brings us to the question, what exactly is a default parameter? Well, a default parameter is simply a parameter with a preset value. It acts as a super helpful safety net. Look at the example here, def welcome name equals student. If you pass a specific name to this function, great, it uses it. But if no argument is passed at all, the program doesn't just crash. It defaults to printing welcome student. It's a great way to keep your code robust and error-free. Moving right along to Section 3, returning values and how we get data back out. Okay, so we've mastered putting data in, but a true function needs to give us an answer out. Let's test this with a quick multiple choice question from the quiz. What does the return keyword actually do? Does it A, stop the program entirely, B, print the value to the screen, or C, send a value back? If you guessed C, you are spot on. It sends a value back from a function. Now, what's really interesting about this concept is the implication of that return. You see, unlike a simple print statement, which just flashes text on a screen and then vanishes forever, a returned value is tangible data. You can capture it, store it in a variable, run it through a loop, or use it in an if statement later on. Let's talk through this snippet to see exactly how that capturing works. We have a function called add that takes two parameters, A
and b. Inside, it literally just says return a plus b. Then, on the bottom line, we call add 5, 3. The function calculates that 5 plus 3 is 8 and returns that 8. Notice how we catch it? We catch it right there in the result variable. So now result holds the number 8, and we can do whatever we want with it.
Now prepare yourselves, because the notes highlight an absolutely fantastic feature here. This is Python's superpower, multiple returns. In a lot of older programming languages, a function can only return one single thing. But Python lets you return multiple values all at once, just separated by commas. Look at the example, return a plus b, a times b. You can capture both of those distinct answers simultaneously by simply writing sum product equals stats 3, 4. It is incredibly efficient and just a massive advantage of writing in Python.
All right, let's shift our focus to Section 4, local versus global scope and variable boundaries.
You can think of scope as the specific jurisdictions where your variables actually exist. Here is the clear definition of those boundaries. Local variables exist only inside the function where they were created. The moment that function finishes running, boom, those local variables are destroyed and forgotten. Global variables, however, exist outside the function. They live in the main body of your script and can be seen by absolutely everything. I really have to warn you here, for beginner programmers, confusing these two jurisdictions is a very common source of frustrating bugs.
And this brilliantly illustrates exactly why it can be so confusing. Look closely at this code. We have a variable named x set to 10 at the top, so that's in the global scope. But inside the show function, we have x equals 5. That is a local variable. Even though they share the exact same name, Python treats them as two completely separate entities because they exist in different jurisdictions. The local x will not overwrite the global x. Really understanding this distinction is going to save you hours of debugging down the road.
And we finally arrived at Section 5, the power of modular programming and building better code. This is the culmination of every single thing we've learned today. The notes provide an excellent example of breaking a complex program down into small, distinct, manageable tasks. Instead of one giant, messy block of code to grade a student, we modularize it. Step 1 is handled by an input marks function, whose only job is to get the number. Step 2 is handled by a grade function, which takes that number as an argument and returns the letter grade. Step 3 is just printing that final result. The beauty of this is, if the grading scale ever changes, you only have to fix the grade module. The rest of your program remains totally untouched and perfectly safe.
Let's move to the next logical step and see how this all builds together. The Bootcamp notes actually give us a sneak peek at day 6, which is all about file handling. We're going to be reading and writing text files, processing real CSV-style data, and permanently appending student records. And guess what? The skills you learned today, creating those distinct modular functions, will directly apply to handling these actual files. You'll build a module just to read the file and another module just to process the data.
We've journeyed all the way from writing messy, repetitive scripts to designing clean, highly efficient, and reusable modules. You really have the architecture in place now. So I want to leave you with this final, exciting thought. Now that your code is beautifully modular and ready for action, what massive datasets will you feed into your custom functions when we master file handling in the Day 6 Explainer? Get those ideas ready, keep practicing your Python, and I will see you in the next one.